Okay, we're ready to begin lesson 4.4. It has two main objectives in there to graph transformations of sine and cosine functions. The book is making a big assumption that we know what a sine and cosine function, the parent functions, look like already, and they're going to apply transformation. So we're going to go back and get a little background information on how to graph a sine curve, how to graph a cosine curve as our angles go around and around the unit circle. Then we're going to use the sinusoidal functions to solve problems. So first thing we're going to do is we're going to try to figure out how to graph a cosine of theta, and then we'll figure out how to graph a sine of theta. And we're going to use the unit circle to help us drive home this idea, and we're going to graph it along the x-axis and the y-axis. So what happens as we wrap around more and more times? So just as a real quick illustration here, we already looked at this. This is a pretty decent illustration, although it's not completely correct and accurate in all of the diagram here. But what I want to do is point out, when we looked at quadrantal angles, if I had an angle that was exactly 0, then our order pairs here would be 1, 0. As we rotate around the circle from 0 degrees or 0 radians to pi halves, we see that the x values increase in value. The x values decrease in value and the y values increase in value. So from 0 to 90 degrees, or from 0 to pi halves, we see that the x values start at 1 and they go down to 0. So our order pairs that we talked about align with that. And our y values, which started at 0, the red numbers, start at 0 and they work themselves up to 1. Of course, that's because the length of the radius of the circle is fixed to 1. As we rotate around from pi halves to pi, or 90 to 180, we see that the reversal is true, and this is where my numbers are a little inaccurate. Since we're to the left, these x values would be negative. So really they're taking on the correspondence of a negative. All the values of x are negative here, but they're going from 0 all the way to a negative 1. So the x values work themselves from 0 to a negative 1, and the y values are working themselves all the way from 0, or from 1 all the way down to 0. So the red line approaches 0. These are things and ideas that we talked about before. So now the x values are decreasing from a negative 1 to 0, and the y values are going from 0 to negative 1, and all the way back home to where we started, and we will start repeating the values. And this is where it becomes periodic. The values just keep recycling over and over. They're called cyclical functions because they cycle through their values. So what I want you to think about on the unit circle is, here's the main idea, is that if we do the cosine of any angle theta, and as we wrap around this circle, if we do the cosine of 0, it's 0. But here's the first concept, it's always x over r. But because it's a unit circle, we've discussed this before, the cosine of theta is nothing more than just the x value, since r is 1. And then we can do a similar analogy that the sine of theta has got to be equal to y over r, and because r is equal to 1, the sine of theta is simply just the value of y. So when we look at any ordered pair on this coordinate plane, the cosine of theta is the x-coordinate. I was thinking x and theta at the same time. So the cosine of theta is the x-coordinate, and the sine of theta is the y-coordinate. So they represent your x and y's in your ordered pair. Those x and y ordered pairs are what we're going to be graphing whenever we graph the cosine of theta. So now I'm going to jump over to another illustration here. In this illustration, I got to clear this out. This illustration will kind of get you a feel for what it's going to look like. If we're going to graph the cosine function, we start with a unit circle. We want to start at a 0 radian or 0 degree radius, and this has an animation here where it starts drawing. So the cosines always measures the x-coordinate. So we're going to start at a value of 1, and as we allow this to go, it starts at its maximum value, and then the x's approach 0 till when we get to 90 or pi halves, and now they reach a value of 0, and now they approach negative values. So as the cosine values measure the x values, you can see that the x values go from 0 to negative 1, and then they start working themselves back to 0 again, because at this order pair, at 3 pi halves, our order pair would be 0, negative 1, but cosines are only the x values. So really when we're graphing the cosine curve, all we're doing is graphing the x values of our order pairs as they go around the unit circle. So our x values would start at a high value of 1, curve around here where they're at 0, so this is pi halves on our horizontal axis. So what we're measuring is, on this axis here, this is our angle of theta. And as theta goes around, we start at 0 radians, and then we work ourselves halfway around the circle. Now we're at pi halves. But at pi halves, our x-coordinate was 0. So 0, 1. So it records 0. Cosines will always record the x-coordinate of your ordered pair. Then as we wrapped around to pi halves, so this has to represent pi halves, we hit our lowest point where x is equal to a -1, and this was a positive one. We keep wrapping around the circle, and the next value that we hit is 270, or 3 pi halves. At 3 pi halves, we have to have an x value of 0. So this one, where it crosses that axis, is 3 pi halves. And then finally, as we wrap completely around to go to 2 pi, then our x values have to be back to a value of 1, because now we're at the order pair 1, 0. So what we're doing is we're taking these order pairs around the unit circle, and we're going to be graphing them depending on whether it's a sine or cosine value. So since this is a cosine value, the cosine of 0 is 1, graphed it. The cosine of pi halves is 0, graphed it. The cosine of pi is -1, graphed it. And the cosine of 3 pi halves is 0, and that is graphed. And then once we work all the way around, the cosine of 2 pi is 1. And then if we allow this to continue, this is a wrapping function, which means it wraps around that circle repeatedly over and over again, and this curve would simply continue the curve that it has already created. So this is a periodic curve. What we're looking at is a period of 2 pi once around the circle, and once we get back to 2 complete revolutions, we can see that we've done 2 cosine curves. So it gives you a little bit of idea of what we're graphing, and here it comes back. And cosines always graph your x values. The second curve that we're going to graph is the sine curve. Now the sine curve does almost the same thing, except sines always graph your y coordinates. So as you watch this graph go around, it's going to start with what is the y value of your ordered pair. Well, at 0 degrees, our y value is 0. Then it's got to work up towards its maximum value, which is going to be the highest point of 1. Then as it comes down, it's got to work back towards 0. Then it's got to work down towards its lowest point on the y-coordinates is a -1. Then it's got to work back towards 0. Now this is what they call one period of the sine curve. When we rotate around the circle one time, that's one rotation, so that's one period. After that, we'll cycle through the same values over and over again, so they are called cyclical functions because they cycle through their same output values from one rotation to the next. So we've got wraparound angles, we've got periods, we've got cyclical functions, all kind of denoting some of the same ideas here. So those are some animations I wanted to show you. Now just to graph a little bit by hand, I want to reinforce a few ideas here. And if you've already got it, fantastic. If you don't, you can bear with me, and I'll try to explain a little bit more. The first curve I'm going to graph is the cosine curve. Now theta is the axis that we're graphing on. Theta represents the x-axis, because this is the input value, and we're going to graph the output values. The cosine of any angle theta will always grab your x-coordinates of your circle. So in a unit circle, this ordered pair is 1, 0, and this ordered pair is 0, 1, and this ordered pair is -1, 0, and this ordered pair here is 0, -1. So when we take the cosine of every one of these angles, we could take the cosine of a 0 radian measure. That cosine value is 1. We can take the cosine of pi halves. I'm going to do this in radians, and that cosine value is 0. And then the cosine of pi is equal to the x value of that coordinate, which is -1. And then the cosine of 3 pi halves is the x-coordinate of 3 pi halves, which is 0. And then the last one is the cosine of 2 pi. That's what I'll start with, and that means we're back to where we started, and it has an x value of 1. So if we were going to do those correlations, when theta was 0, the cosine was 1, and our output is 1. So at a 0 radian measure, not 0 degrees, 0 radian, our output is a 1, because the cosine of 0 is 1. That's what we're going to graph. And at pi halves, we said at pi halves, we had an output of 0, and at 2, this should be a pi, that's a misprint. At pi, we should have a value of a -1. At 3 pi halves, we had a correspondence of 0, so 3 pi halves are back to 0, and at 2 pi, we're back to a value of 1. So the first period of a cosine curve looks a little bit like this as it goes through those cycles of values. Now, as we wrap around a second time, so that was one time around, now we're going to wrap around a second time, and as we wrap around a second time, these wraparound angles are going to be exactly the same. So rather than at 2 pi, it's 5 pi halves. So 5 pi halves wraps around once, and then we're back to 0. So at 5 pi halves, we have an output of 0. At 3 pi, Now we're at a negative 1. Whoops, slide over 1. And at 7 pi halves, 7 pi halves correlates to our 270 because we're going to go around one full rotation and then back to our 270 or 3 pi halves, 0. And 4 pi means we revolved around the circle around it twice completely, and at 4 pi we're back to 1. So here's the second period. Here's the periodic nature of the curve. Every time we rotate around the circle, we start repeating the same output values. This is the cosine curve. It starts at a maximum value, and it finishes at a maximum value. So that's one period. And the period of this is 2 pi. There's a lot of other things the textbooks discuss, but this is the main stuff I wanted to illustrate to you in this part of our lesson. So next one is the sine curve. The only difference on sine curves, instead of harvesting the x values out of our unit circle, it's going to harvest the y values. So this is the order pair -1, 0. This is the order pair 0, -1. So if we start with the cosine or the sine of the 0 radian measure, the sine of the 0 radian measure harvests the 0, the y coordinate. Remember, it's always y over r, and that's a 0 over 1, which is 0. That's all that's being done here. So the sine of 0 is 0, so I'm going to record that. The sine of pi halves. Pi halves is a quarter turn around. We're going to harvest the y value. Sines are 1 over 1, or 1. So at pi halves, we should be at our maximum value of 1. This again was a misprint, so that's pi. At pi, our sine value is 0. At 3 halves pi, our sine value or y value is a -1. And at 2 pi, we're back to 0. This is once around the circle, so this is one period of the sine curve. If we rotate around, these values will be repeated. So a quarter of a turn, we're going to be at a +1. At a half a turn, we're going to be at 0. At 3/4 of a turn, we're at -1. And then completely around the rotation, we're back to our starting point at 4 pi, which is 0. So these are our basic sine and cosine curves. They have an amplitude of 1. The amplitude basically says how far away from the center line that we travel. And our center line on this is called the sinusoidal axis. It's the axis of symmetry for these graphs. So there's some background information I want to get to you, and hopefully this will help clarify what a basic trig function looks like.